Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes.
This video is sponsored by Tagitize, the easiest way to run Tag All on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Tagitize will turn this into this. Try Tagitize completely for free using the link in this video's description. In today's video, I'm going to show you something incredibly powerful and honestly a bit mind-blowing if you're a Revit developer or you want to become one. I'll be showing you the exact AI prompts I use to generate a fully working Revit plugin from scratch using GitHub Copilot inside Visual Studio. Not Visual Studio Code, but full Visual Studio. By the end of this video, we'll have a Revit 2025 plugin built in C# targeting .NET 8 with its own ribbon tab, buttons, a WPF window, and even a command that runs a proper Revit transaction to create walls in the model. And the best part is that most of the heavy lifting will be done by AI, guided by very precise prompts. So let's get started. First, Visual Studio. If you don't already have it installed, go to the official Visual Studio website and download Visual Studio Community. It's free and more than enough for Revit plugin development. During installation, make sure you select the desktop development workload. That's important because we'll be working with WPF and C#. Once installation is done, open Visual Studio. Now let's create a new solution. For the project type, we can start with something simple like a class library using C#. Don't worry too much about the template here because Copilot will help us reshape everything. Give the solution a clear name. Also make sure you create it in a brand new empty folder. This keeps things clean and avoids confusion later. For the .NET version, stick with .NET 8. Although .NET 9 and 10 are also available here, these are not the version used by Revit, so don't select those. Once the solution is created, you'll see the default project with files like class1.cs. We won't need that file for long. Now let's talk about GitHub Copilot. Make sure you're signed into GitHub inside Visual Studio and open the GitHub Copilot chat panel. You can usually find it under View, then GitHub Copilot Chat. This is where the magic happens. Instead of writing code line by line, we're going to describe exactly what we want in detail and let Copilot generate a full Revit plugin architecture for us. Just so you know, the GitHub account I use already has a GitHub Copilot subscription, so it can begin working right away. If your account doesn't have one, it will work for a few requests and then ask you to start a GitHub Copilot trial. In my opinion, this is totally worth it, so please make use of that trial. At the end of the trial, you can choose to continue using this for $10 per month. For me, the time and money this AI workflow can save absolutely far outweighs that small cost, so I highly recommend it. Before looking at the prompts, a quick shout out to our sponsor, Tagitize. With Tagitize, it's never been easier to tag multiple Revit categories at once using your favorite tagging styles. Say goodbye to spending countless hours untangling Revit tags. After running Tagitize on this view, for example, all my tags are perfectly readable. None of them overlaps with their hosts or other elements in the view. If I think this tag, for example, can be placed better, I can just select it and click Next to tell Tagitize to try the next possible tag position. Each time I click the button, Tagitize moves the tag for me, and I can keep doing this until it gets to a tag position I like. There we go. That's much better. Try Tagitize completely for free today using the link in this video's description. Now I'm going to open in the first prompt. This prompt is very important, so pay attention to the structure and level of detail. I'm telling Copilot that I want to turn this solution's only project into a Revit plugin for Revit 2025 running on .NET 8. I specify that the plugin needs to appear on the Revit ribbon under its own tab. It needs to show a WPF window when the button is clicked. Inside that window, there should be a button that searches for all walls in the active Revit model and reports the total count in the message box. Then, I explicitly tell Copilot to check the Revit API documentation and follow correct deployment rules. I specify the add-ins 2025 folder. I specify that we're using .add-in files, not app bundles. I even tell it to use a blank white icon with the correct Revit resolution embedded as a resource and loaded using a pack URI. I also give clear architectural rules. Use MVVM. Use separate service classes for Revit API interaction. App must implement iExternal application. The command must implement iExternal command. Each class goes in its own file. Configure debugging so Revit 2025 opens automatically. Clean up unused files like class1.cs. And finally, make sure the project builds without errors. This level of specificity is the key to getting good results from AI. Now, let's send this prompt to Copilot Chat. I will use agent mode since Ask mode won't allow the AI to create or modify code files. Regarding the AI model to use, let's skip the free models down here. At this important step of building the foundation for the plugin, we need a proper, more intelligent model. My favorite one here is Claude Sonnet 4.5. It's not too expensive and is clever enough for most tasks. Let's send the request now. Once called, Copilot starts by writing a plan for creating the full structure of the plugin. It adds the correct references, it creates app.cs, it creates entry command, it creates the WPF window, the view model, and a Revit service class. It also explains where files should go and how they interact. Once Copilot has generated the code, I can review it and accept the changes. This part is important. AI is fast, but you are still the developer. You should skim the code, make sure it makes sense, and apply fixes if needed. Here, I'm using links in the chat panel to open each file created or modified by the AI to check for any obvious errors. For each file, I can click the Keep button at the bottom to accept changes in that file. If you ever want to fully understand why the AI does things a certain way, simply ask it to explain it for you. For example, I'm sending here a prompt to make the explain its reasoning when creating files in the last iteration. This is a great way to learn more about coding for Revit if you're interested. You can see here it has explained each file created by outlining the structure and purpose of each section in the file. Feel free to review this if you have time. Anyway, at this point, the solution looks like a real Revit plugin project, not a basic class library anymore. Now, let's debug it. I hit Start Debugging. Because the project is configured correctly, Visual Studio launches Revit 2025 automatically. Once Revit opens, I check the ribbon, and there it is, a brand new tab with our plugin button. I click the button. The WPF window opens. I click the button inside the window. The plugin searches the active model for walls, and a message box appears showing the total wall count. That's a fully working Revit plugin, created mostly from an AI prompt. Now let's take this plugin a step further and add a second ribbon button that actually modifies the model using a Revit transaction. I go back to GitHub Copilot Chat and paste in the follow-up prompt. In this prompt, I ask Copilot to add a second ribbon button, not inside the plugin window, but directly on the ribbon. When clicked, it should let the user pick a point in the active view. Then, it should create 4 walls forming a box around that point. The walls should be on the view's level and have a fixed height of 10 feet. I also explicitly remind Copilot to open and close a Revit transaction cleanly. And I ask it to show a message at the end indicating success or failure. Again, this clarity is critical. Back in GitHub Copilot Chat, I paste in the follow-up prompt and then send the request. Just like last time, the AI starts by creating a plan of required code changes. Then, it executes each plan item one by one until the entire plan is complete. I can then review the code changes, try to spot anything that won't work. In this case, all looks good, so I'll simply accept all changes. Now let's start debugging again. Revit still opens automatically as before. If everything goes right, I should see this time on the ribbon 2 buttons instead of 1. The original one that opens the WPF window and the new one that creates walls. And yes, indeed, the 2 buttons are both here. I click the second button. Revit asks me to pick a point. I click somewhere in the view. The transaction runs. 4 walls are created around that point, and the message confirms that the operation succeeded. However, I don't see any new walls created here. Let's check the 3D view to see what's going on. I'll disable the section box to see everything. And there we go. The new walls were generated, but on the wrong level. Parking instead of level 2. There must be a bug in the AI-generated code. Not a build error, but a runtime error, which means the code builds but doesn't function properly. Let me quickly check the relevant methods. Alright, I can see the problem is likely here. The AI tried to get the level of the view using the level ID property. This returned a null value, which then triggered the fallback case of using the first level found in the model instead. To fix this, all I have to do is using another view property called genLevel. This should give us the right host level of the input view. I can now apply the change in Visual Studio and rerun the command. This time, we still pick a point on level 2. And yes, now the plugin can create walls on the correct level of the view. So what are the key lessons from this workflow? First, GitHub Copilot is incredibly powerful when you give it precise, structured prompts. Vague prompts give vague results. Detailed prompts give you production-ready architecture. Second, you can absolutely use Copilot inside full Visual Studio, not just VS Code, for serious Revit plugin development. Unlike in VS Code, the full Visual Studio allows GitHub Copilot to build the project, check any build errors, and fix those immediately. This autonomy allows the AI to give the best possible outcome with a minimal amount of prompts. Third, AI doesn't replace understanding the Revit API. This will allow you to identify and fix any small bugs that the AI-generated code may contain, like the one with the view host level before. But it dramatically speeds up boilerplate, structure, and setup. And finally, this workflow scales. You can use the same approach to add more commands, more windows, more services, and more advanced logic. Before you go, check out our sponsor, Taggetize. Save all your tagging styles in one place and tag one or several views or sheets at once. Also, say goodbye to overlapping tags. Simply review generated tags and make any final tweaks with the handy tag audit commands. Try Taggetize completely for free using the link in this video's description.
If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.